This video is going to look at two more of our trig functions, and that's going to be the cosine function and the secant function. So when we define the cosine function, we're going to abbreviate that as COS, and the definition here is going to be x over r. So before we looked at the sine function, which is y over r, so cosine is looking at the x value divided by the radius. So once again, we're using the unit circle here. So if we want to find the cosine of 0 degrees, or in this case I'll use the radians. If we want to find the cosine of 0 radians, then we're going to now look at the x value, which is 1, and remember the radius is also 1, so that means we would have 1 over 1, which is simply equal to 1. And if we go around the unit circle, then we could take the cosine of pi over 6, and remember, pi over 6 is the same as 30 degrees. And once again, now we're looking at the x value, which is the square root of 3 over 2. And that would simply be the square root of 3 over 2, or, square root of 3 over 2 all over 1 for the radius. Or in this case, we could just simply write the square root of 3 over 2. And then if we continue around, the cosine of 45 degrees, or pi over 4, again, we're simply thinking of the cosine, so we're looking at the x, so that would be simply the square root of 2 over 2. And then we move up to the angle pi over 3. We take the cosine of pi over 3. Again, if we look over here at pi over 3, the x value is equal to 1/2, so that would be 1/2 over 1, or simply 1/2. And then if we move up to the top of the circle, we would get to cosine of pi over 2. And again, the x value there is equal to 0. And that would be 0 over 1, or in any case, that would still be equal to 0. All right, so that is defining the cosine function here as x over r. The secant is going to be the reciprocal, and we're going to abbreviate that as SEC. So if we take the secant of theta, let's see, I left out the angle over here. If we take the secant of our angle theta, it's going to be the reciprocal. Just like in the trig function in the previous video, when we had sine, we looked at cosecant as a reciprocal. When we have cosine, secant is the reciprocal, so it's going to be r over x. So therefore, if we look at the secant of 0, then we can simply just look over here what we had for cosine. It was 1, so if we take the reciprocal, that would simply be 1 over 1, which is equal to 1. And then we want to look at the secant. If we start and go around the circle for pi over 6, and again here the x value, looking at the square root of 3 over 2, so therefore the reciprocal would be 2 over the square root of 3. And then if we continue, we could then take the secant of pi over 4. And there we would have our x value square root of 2 over 2, and again we would take the reciprocal, so that would be 2 over the square root of 2. And I guess really I should go back here. We had 2 over the square root of 3. Typically you're going to rationalize this like we did before, so let's multiply by the square root of 3. So then the answer would be 2 square root of 3 over 3. So again, typically you're going to see this with the square root in the numerator instead of the denominator. So we would do the same thing for the secant of pi over 4. So here we could multiply by square root of 2 over square root of 2. And we would end up with 2 square root of 2 over 2, or simply the square root of 2. And then if we continue up to pi over 3, if we take the secant, here once again we're looking at the x value, and the x value is 1/2. So if we take the reciprocal of 1/2, that would be 2. So you can see it's really easy. If we know the cosine, then we obviously know the secant, because all we're doing is taking the reciprocal. And then if we take the secant of pi over 2, or again we could think of that as 90 degrees, we're looking at the reciprocal of 0. And here we need to be careful, because that means we would then have, this is technically 0 over 1, so if we take the reciprocal, we get 1 over 0, and we've already discussed how that would be undefined because we cannot divide by 0. Okay, so this function is undefined at pi over 2. And that's going to be the case anywhere on the circle that you end up with a 0 in the denominator. Okay, so if you think where else on this unit circle are we going to have a x value of 0? Well, if you said down here at the bottom, this, remember, would be at, the angle would be, well, this is what, all the way over here is pi, so that's 1 pi and another half, so that's 1.5 pi, or 3 pi over 2, and we know the coordinates of this point are 0, -1. So if we think about taking the secant of 3 pi over 2, once again, we're going to have this x value as 0, so therefore the secant at 3 pi over 2 would also be undefined. So keep that in mind with any of these trig functions. If you ever end up with 0 in the denominator, you know that that function is undefined at that particular point. All right, so once again, make sure that you go back and you memorize this for the cosine. And if you memorize cosine and secant are together, all you have to memorize is x over r for cosine, because then the secant is going to simply be the reciprocal. So at this point, quick review, remember the sine of theta, the sine function is y over r, cosine is x over r. So typically you want to think of sine as your y, cosine is the x value. And then of course the cosecant and secant are what we call the reciprocal functions.